In this tutorial, we're going to fly the Concorde in Microsoft Flight Simulator 2020. Absolutely beautiful plane, flew first 1969. It's the only supersonic commercial airliner, if you forget the Tupolev. And very old, very manual flight, very loud. So it needs a lot of planning. So it's not just an easy plane to fly, but of course it's very much fun. The problem is that you have to especially take care of the weight and the load. The center of gravity is absolutely important, so you can establish a stable supersonic flight. You have a very narrow Goldilocks zone that you need to achieve, and you miss that, you have an unstable supersonic flight. So before we can go into Microsoft Flight Simulator, we need to take care of the planning of the flight, which is, again, more important with this manual old plane that has not an automatic load balancer and the modern tools that you have in a PMDG or in a fly-by-wire A320. So we have to do everything manual. That includes the planning for the fuel. So we're going to start first in an absolutely indispensable tool. It's called LittleNavmap. Open source, you can download it. You find, as usual, the links to the tools in the description. And what is important, you have to plan a straight route. So do not follow the usual procedures, because in supersonic flight you don't want to maneuver. So we need to have a straight flight path. What is important is the fuel, the planning. You cannot just take a little bit more fuel, 10 tons more fuel, as you would do in another commercial jet, because you're very, very limited in weight, and again, the center of gravity is absolutely important. So you need to create a new performance file. I included one, you can download one in the description. And I'm going to open the performance file for the Concorde. Now, in this performance file, you have certain information, Concorde type, description, and of course what is extremely important are these numbers. How much fuel are you going to use in climb, in supersonic flight, etc. So you can plan your fuel. If you did that, you need to load a flight plan, which I'm going to do. Again, very, very simple. You need to stay simple. So we're going to fly from Paris to Cairo, and you see this is a very straight flight plan. Has the added benefit of crossing the Alps, a nice region that we're going to have a look at, traveling Italy, Greece, and then arriving from the north into Cairo. What, again, is extremely important is the loadout. So we need to talk a little bit about the tanks in the Concorde. As you see in the picture, there are 3 different systems. You have the yellow system, 1, 2, 3, and 4. These are the engines. And they are fed by the fuel transfer tanks 1, 4, 2, and 3. You see 1 and 2 is on the left side, and 4 and 3 are on the right side. They're not interconnected. So you need to be careful to load accordingly, that all the engines have the same amount of fuel. The blue tanks are the main tanks. That's where the main engine weight is. And you see again, you have tanks that are more in front of the aircraft, 5 and 6, 5 and 8. And tanks that are more in the back and on the outside, 5A, 7A. And for the departure, we need a center of gravity of 54, which is at the front of the airplane. And in supersonic flight, we're going to trim the plane with the fuel at the back to 59% to have ideal conditions for supersonic flight. We cannot do that with trim. Concorde does not have trim ailerons or something. There's just too much drag in these speeds. You cannot work with trim surfaces, so we need to trim the plane with the tanks. Again, for descent, we need to trim forward again to 45%. So we need fuel in these green trim transfer tanks, and we need to operate pumps and valves, etc., to move the fuel around. This is very, very particular to Concorde. You don't have to do that in any other plane. It's all automatic. And the center of gravity is not a problem either. So we have very special conditions. That's the attraction, at least to me. It's a bit more fun than the automatic planes that, of course, I also fly. We need to use, and that is a problem, the very clumsy interface of Microsoft Flight Simulator for the weight and the tanks and the CG. So you have to do it in there. You see a picture for this flight. We saw in the fuel report that we're going to need about 120,000 pounds, and usually Concorde is in kilograms, the tanks are in kilograms, but the interface in Microsoft Flight Simulator is in pounds or gallons, and we're not going to use gallons. So we need to have about 120,000 gallons. We have 121. We have a CG of 53, which is okay, and I cheated a little bit with the added payload, so we are a bit heavier because I put more passengers and baggage in the back to again achieve a reasonable takeoff CG of 54, but in this case 53 is okay as well. So we're going to load these numbers in Microsoft Flight Simulator and then start cold and dark at the gate at Paris Charles de Gaulle. See you in Microsoft Flight Simulator. We are cold and dark at Paris Charles de Gaulle Airport at gate K76, and we loaded the aircraft as we discussed in the intro, with the specified amount of fuel and the correct center of gravity. So now we are able to start her up. Inside Concorde you should have a few camera views defined, so you can really easily access the important parts of the aircraft. I'm going first to the engineers panels to have some light. We're still in the morning. So the first thing you want to do is close the circuit valves, electric circuit. So you have lights. You're going to turn on the batteries on the right side of the engineers panel. You have two batteries, left and right. If you turn them on, you have everything coming up. Now this is my first camera. This is going to be taxi, landing, etc. You see the autopilot here is accessible. That is important. You see the important information, airspeed, your climb speed or descent speed, altitude, etc. You have the VOR visible for the approaches. You see a little bit of the center of gravity on the bottom here, which also is accessible, are the lights up there, and of course the autopilot panel, which is important. We're gonna use manual thrust most of the flight, just if we have to achieve some certain speed, 250 knots below 10,000 feet, we're gonna use the auto thrust. Without the afterburners. The afterburners you only use in certain phases of flight. That is because noise problems in lower altitudes and above 1.7 Mach. The afterburners do not have any more effect. You're just burning an enormous amount of fuel. So auto thrust is not going to be used. Of course, in every other modern aircraft you're constantly on auto thrust. What we're going to use is INS, which is going to follow our very simple flight plan of Microsoft Flight Simulator. That is easy. GPS is working fine. The problem with the autopilot is that all the altitude modes are not really working. So especially max cruise, which usually climbs the plane very, very slowly to keep a certain max speed, is not working. It's much too clumsy. You're going to end up in a frequency up and down, and you're going to lose stability. So everything we're going to use of the autopilot is actually alt-acquire. So we're going to have to fly manually and react to a plane that is getting lighter because we're burning fuel, and constantly climb so that we are not overspeeding and overheating. That is going to be our main problem. I'm going to down to very important view. FMC is not that important in this plane because again you have to do everything manually. GPS of course we're going to set, etc. But important is the left side where you see the Mach number, altitude, outside temperature, and especially on the right side you see the temperature of your airplane, especially the nose, and you cannot go higher than 127 degrees Celsius, otherwise you will hear a very annoying alarm and you have to correct immediately by going higher and reducing air and temperature and speed versus density of air. Another camera angle that is important I show here. Here you have the control of the afterburners. Do not let them be turned on if you're in auto throttle, or your autopilot's going to use the afterburners if you don't want them to. So you turn them on and then they are available either with autopilot or your manual thrust. Down here you set the transponder, otherwise you have the parking brake, which is not very well accessible otherwise. That's why this view is also important. On the overhead panel you have the usual lighting, landing lights, taxi lights, etc. on the back, on the lower end here of the view. Anti-stall systems, the different stabilizer systems that need to be turned on. Up here you have the throttle control, and we will have to change the engine flight rating from climb to cruise once we achieved our desired supersonic flight. And otherwise you do not have to turn on a lot of things. You have the anti-icing if needed, and on top here you have the light and seatbelt signs. From the overhead back to the engineers panel where we started with our electric systems. We still need to do a few things. And here in the middle, everything important visible, that's a very important view, you're going to spend a lot of time here, are the tanks, the tank system. Just to remind you, we have different tanks in Concorde, and they are represented here on this panel. You see the number, we have 9, tank number 9 and 10, the two trim tanks in the front up here. We have input valve, so if ever we need to put fuel back in these tanks, we're going to turn these valves on, they open up, and now if ever we would turn the power in pump in tank 11, which is down here, we would turn the pump on, then we would pump fuel from the back to the front of the aircraft, and therefore change the center of gravity, which is indicated here in the middle, which is at 53.2% right now. It's trimmed to the front, which is okay for departure. And you also see the total amount of fuel that we have here in kilograms, 54,000 kilograms, which is correct because Navmap and Microsoft Flight Simulator, we had 120,000 pounds, which corresponds. Next in our tank system we have two particular tanks, which are 5A and 7A, which are not correctly indicated here. Their position is much further back, so they should actually be down here to represent their position in the plane, and they have to be full at departure, which they are, and they need to be emptied once we approach our final supersonic speed that we want, Mach 2.02. This is important to adjust the aerodynamics of the plane wings, because they're located at the wings outside, 5A, 7A, and if they're emptied, the geometry of these wings change and they're optimized for supersonic flight. So another thing we have to consider. Now we're going to start up the plane. We already closed the ground power circuit, so we are on ground power, which is controlled here. and we already turned on our two batteries, battery A and B. So we do a minimal checklist with all the important elements to get you ready for takeoff. We have to turn on the APU on this guarded switch, and we are going to close the CSD circuits on top and guard them again. We're going to turn on the fuel heaters. We can, they're on the left side. We can turn them to automatic, so we don't have to take care of them later on. Next, we have to look up a little bit, otherwise you're not going to use that part of the panel in flight. We have going to turn the air bleeds on, and first one already turned on because we engaged the APU. Back down on the electronics APU, on the engineers panel, we have our fuel pumps. They're turned on by default, and we are gonna close the fuel valves. Turn on the cross feeds. That for the moment was it for the engineers panel. We have to change the mode of the airplane due to noise. That's a simple noise restriction that we have to do. We're gonna go to the overhead panel and turn on the fasten seatbelt and turn on the beacon to indicate that the plane is on power. We're gonna turn on the stall system back down here and engage all the stabilizer systems that we need to help us stabilize the plane. What you can also adjust here is the lighting of the different sections of the plane. I usually turn down console because this is irritating light. On the right side you have more lighting options. That's it for the overhead panel. We have to program our autopilot and FMC. FMC again is not that important, but still it has to be managed. We're gonna put on our first speed that we're gonna achieve with auto thrust 250 knots below 10,000 feet, and we're gonna also put in 10,000 feet as our first desired altitude. By clicking you can change what you changing. 100 feet is going to be important later on, but now we just want to have 10,000 feet. We're going to turn on flight directors. Later on, if we engage auto thrust, we're going to click indicated airspeed acquire to reach 250 knots. We're going to click INS, so the airplane is going to follow our very simple flight plan, and altitude acquire to reach 10,000 feet. The navigation can be changed from RAD, so you're following your own VOR tracks and radials, or change to INS. That is important if you click here. So the VORs and receivers are automatically going to be tuned to the VORs in your flight plan. We're going to stay on track, and we're going to put in our runway heading to 6 right, left that we're going to use today in Paris. To 6-4. In the FMC you have the usual configuration menu. First the position monitor, and you input, as you know from other planes, the GPS position. You can put in the reference airport, which is a bit clumsy. You have to navigate like on old phones, L, F, P, G, but it's possible. And we are at gate K. I don't think this has an influence. 74. Next thing we're going to input is data, and you just enter a flight number. So this field has to be 2 digits. Your cost index 100 is usually fine. The flight level that we try to achieve 520. Departure is okay. Wind is not relevant because we are on a standard atmosphere. By clicking previous or next, you can change pages, and this init page has a second page. We see our block fuel, which is correct. We already checked that. Landing, CG, etc. you can find on this page. It's just to control. And as the sun comes up, the light just changed. We need to continue with performance. There you have the usual information, pretty correct, and you see we are gonna be very, very fast before we can rotate. We have a V2 of 215 knots, extremely high for a commercial aircraft. Different information, 09 left, no, we're gonna depart from 23, 26 left, but never mind, this is not important. Flaps we don't have. Everything looks okay. I have a transition altitude of 18,000, but of course this is not important since we're not going to use air traffic control. Climb, everything standard. Cruise, descent, and the approach you can also fill out, so the airplane knows what it's doing. For the last information to put into the FMC RadNav, the ILS frequencies, we quickly have to go back to Navmap and check the approach. Of course, we have the different approaches that we could choose if we would fly a standard aircraft, but we are only interested in the ILS frequency and the radial to fly. So once we have this information, we go back and put this in. ILS frequency 109.5, and we're gonna put this in 4 times, so just to be sure that all the receivers on both sides are pre-programmed for the ILS. With the CRS of 224, oops, sorry, click that one too fast, 224. The FMC is now programmed and already ready for ILS approach into Cairo. With this, we are ready to start our engines. That's a view that you don't really need that often. There are the start switches of the engines, which have to be started in a particular order. You start with engine number 3, you put start, and you can check if the engine numbers are coming up either on the front pedestal but also in the engineer's view. On the left side you have fuel temperature, oil temperature, PSI, which are going to go slowly up until the start switch is going to go back. That means you can continue and start up the next engine. Engine 1 is up, and we're going to start the rest of the engine, continuing with engine number 2. Now our engines are running. We're going to turn on some lights, and then we are going to taxi out to runway 26 left. We're at the holding position of runway 26 right. We have to do a few checks and turn on lights, and then we're gonna put the visor and the nose down once we're on the runway. We should have done that for taxi, but it might get an annoying alarm if you have your engines on standby or on idle. So we're gonna do that on the runway. We're gonna climb straight out 250 knots, 10,000 feet, and then we're gonna climb to flight level 240 with 340 knots, and at that position in time and place we're gonna go to Afterburners and climb to our supersonic flight profile. Just turning on some lights. Taxi light turn off on. Landing lights are on. Valves are closed, pumps are closed, CG is correct, engines flowing, reheaters on. Usually about 71% N1 is good for taxiing with the heavy weight that we have. Turn on the afterburners, possible if you give full power. Spool up the engines. Brakes release, full power set. 3, 2, 1, go. Timer on. Knots. Stick forward. V1, rotate. Positive climb, gear up. Nose up. Three, two, one, noise, afterburners off. Auto throttle on, indicated airspeed acquired 250, autopilot on, INS, altitude acquired, afterburners off. Now we're going to climb to 10,000 feet, increase our speed, climb to 240, and then start our ascent or climbed with max power to our flight level about 520 and Mach 202. We are at 10,000 feet, increasing altitude to 40. Still altitude required, but we're gonna also increase our speed to 340. Approaching 24,000 feet, still on the outskirts of Paris. Right above Orly, our first waypoint, we are. And now we are coming to the interesting part of our flight profile. Up until now it was fairly common. 340 knots, 24,000 feet. We are gonna go off autopilot as soon as we reach 24,000 feet. We are gonna go to altitude hold, engage afterburners, and then engage a mode that works well, luckily, max climb, which is gonna lead us pretty exactly to 45,000 feet at Mach 1.7, where we're going to disengage afterburners, as again they have no effect at that altitude. Continue to climb to 50,000 feet, continue to accelerate to Mach 2.02 if possible, and then do a slow climb to whatever altitude is suitable for our weight and temperature and speed. Since we are beginning our supersonic envelope of the flight, we need to commence to trim. Quickly gonna go to the engineers panel. We need to engage the pumps of tank 9 and 8. 9 has more effect, it's more in front, and we're gonna open the inlet valves of tank 11, which is at the back, to trim the CG to the back of the airplane as we are starting our climb. So this is going to be a dynamic process. Start the pump, stop the pump, etc. till you reach 59, and you need to stay inside the yellow markers. Up until now it was not a problem, but now it becomes important to be aerodynamically optimized. We go to altitude hold, disengage auto throttle. We're gonna pre-engage the afterburners, go back to our panel, select 45,000 feet, start to climb, engage max power, and go to max climb. The max climb mode is a lower ascent rate. You can see it here, it goes back. So it is a balance between gaining speed and gaining height. If you're getting too fast, for example, above 45,000 feet, you can always go to Alt Acquire, which keeps the speed but maximizes the gain in height. As we are starting this ascent, this view gets important. We are approaching Mach 1.0. The temperature at this altitude and this speed is not a problem, but this is going to become extremely important to control. You can also see every information you need on the engineer's panel, and we are going to start our pumping process. Pumps on, inlet valves on. You see we are at 0, tank 11, and this should start to fill up. See 100, and it's going to slowly increase our center of gravity, and depending on our altitude you're going to just turn off the valves and wait till you need to turn them on again. As we have now crossed Mach 0.1 and are steadily climbing and accelerating, you need to control your CG. I'm a bit behind with the trimming, but I'm gonna catch up. As we are supersonic, we are now in a cone of silence, where the airplane is faster than the sound it creates. And with the trimming you can see we're catching up. Height going up and speed going up. With still a reasonable temperature, but again this is going to come up very soon. Still climbing and accelerating. We are now at Mach 1.5. At Mach 0.7 we're going to turn off the afterburners. Our trim situation is good. We're approaching 49. Still have some fuel left. I might have taken a bit too little because we have to empty tanks 5A and 7A, and as they are not correctly represented, they are gonna increase our trim to the front, so we have to trim more back. I still have fuel in number 10, which does not have that big an effect and is not as large. You see 3,600 kilograms, and I'm almost empty, but correctly at almost 59, so that was calculated correctly. Tank 9 is empty, so I can close those pumps. They will not have an effect anymore. I'm going to close the inlet valves just to be sure that no other fuel is flowing. For the moment, we are trimmed correctly. Approaching 1.7, where we're going to reduce speed, the thrust without the afterburners. Remain on 100% and continue our climb to 50,000. Afterburners are off, max power remains, and 50,000. I go to Alt Acquire to not build up too much speed, gain a bit of altitude, and go back to max climb. Temperature is good, but it's also in relation to height. So we are a bit low for that speed. I hope we don't hear that very, very annoying alarm. Perfect silence outside. Inside, Concorde was a very noisy plane. Here a view from passenger seat, and it is much louder in reality. Forgot to go back to max climb, climbed too fast, lost some energy. I hope it's gonna stabilize. Talk too much, concentrated not enough. We're still good. Speed is coming up. So we're gonna still accelerate to Mach 2.02 if possible. Might have to descend a little bit. rose too quickly, just missed the Goldilocks zone. Not too bad. I guess I can stay at that altitude, but it's going to be a long climb, long flight to achieve Mach 2.0. Might descend a bit to accelerate, but again, this is going to disturb our smooth flight. As indicated, I'm in a little bit of trouble here with my stability. Temperature is rising, already 104. I was not accelerating quick enough. I had to descend 1,000 feet. Hopefully this gives me a few more indications of speed before the temperature is rising too much, because then I will have to climb again. So exactly missed that Goldilocks zone, that perfect little envelope, but trying to regain it to have a smooth rest of the flight. Now we're steadily climbing with about Mach 2.02 to 55,000 feet for the moment. We have to do some housework. We have to start pumping fuel out of the wing tanks, and this is going to affect our center of gravity. So we have to again pump fuel to the back. We're going to change before that the engine rating to cruise. So this is going to slow down the outlet valves. Transfer process is pumps are always on, so you don't need to open the pumps, you just need to open the inlet valves of tanks 5 and 7, and our CG is gonna go back as this fuel flows, so we have to open pumps tank 9, 10 and the inlet valves of tank 11, and hopefully get them more or less in balance, or otherwise stop the pumps so we can catch up, because the fuel flow is quite a bit more in this direction here than from the front to the back. But you're seeing I'm keeping it more or less in range, even too much flow, so turn off pumps from 10. The fuel transfer process has finished. Tanks 6, 5A and 7A are now empty, so aerodynamically perfect for this phase of flight. We still have 1,000 kilograms, 1 ton in tank 10 to compensate for burn fuel, which usually is at the back of the plane. So constantly trimming a bit of the remaining fuel should be perfect actually to the back to stay at 59%. We are at Mach 2.04. Temperature is getting close. I think I need to climb again, so this is a constant process, but we have regained the energy and are in a stable supersonic flight. Even as the situation is stable right now at flight level 570 at Mach 2.04, temperature is always very close and you have to be very careful. Climb maybe by 300 feet climb it, let it establish, or maybe 500 feet, but not more, or you're gonna lose energy. And you have to descend 7,000 feet to regain it, if your flight time even permits that. So be very careful, even once you are established. The plane is trimmed correctly. It's a delicate situation. We are still established in supersonic flight, a bit too slow at Mach 2.02, 04 will be better, but our temperature is okay. And for the moment, 56,700 feet is the ideal height for our fuel situation, where both the fuel tanks 5A, 7A are empty. Main trim transfer tank in front 9 is empty. We have 1 ton and 10 left. A bit less fuel on the right side than on the left. That is the problem of this clumsy Microsoft interface. We might have to pump the last ton to the right side here. That we do by opening valve here, or for tank 7 here, and operating the pumps as before. For now we're even accelerating a little bit, so another little climb is necessary to stay in this balanced flight. 300 feet, let establish, few minutes, and climb again. We are about 300 miles before our point of descent, which we have calculated, or it was calculated for us in Navmap. You see about 100 miles before we are port side, which is actually in the moment in the VOR, because we are on INS mode. So the VOR port down here, that's automatically programmed in this INS mode. That we are going to change once we're in approach. Automatically indicates our distance, 400 miles. Top of descent is 100 miles. So at 100 miles we're going to reduce speed to again 350 knots by simply pressing altitude acquire, and we're going to descend to 36,000 feet. Also altitude acquire. That should slow us down, and meanwhile descending. When we reach this flight level 340, we're going down to descend to 240, again reduced to 325 knots, and then to 10,000, 250 knots. Switch to RAD. We have pre-programmed our ILS, so we should find the runway no problem. Glide is working really well, so you can automatically land, but we are gonna turn off autopilots and auto thrust at about 1,000 feet and land manually. Fuel situation is not too good on the right side, but it's enough to reach our destination. If we'd had to reach an alternate, we would need to pump fuel where we still have enough to the right side of the plane. But for now we should be good. rapidly approaching our point of descent. Concorde made it to almost 60,000 feet. We're at 59,300, stable at 204, right at the edge of the temperature. Our trim is still good. Fuel situation has gotten worse, but we are gonna descend soon and are not gonna use too much fuel again. For an alternate, the situation would become problematic. Approaching our descent point, we're gonna quickly go to Navmap to do some sort of approach briefing. You see the point, top of descent, marked in Navmap, about 110 miles before Port Said VOR, where we're gonna turn quite heavily into our intercept course, and we need to be at 2,000 feet entering the ILS for runway 23 center. Our final numbers, we would have to reduce speed, are 206 at flight level almost 600, and the DME here 136. So we are going to start our descent to 340. Auto throttle on, altitude acquire. We see the throttle spooling back. We give them some time, and we go to 36,000 feet. Our descent has started. Speed is coming down. Bit early, but we are in the descent to Cairo. The trim situation is starting slowly, but we can start to pump fuel to the front again. It's not that important, as we do not want supersonic flight. We're not in that close an envelope as before. But still, this time we're gonna open the inlet valves on top until they're both open, indicated by these lines. Those of course need to be shut, and as soon as we turn on the pumps in front, we are at 10,300. You see it starts to pump fuel to the front. Constantly monitor this. You could do it automatically, that's no fun, with numbers put in and automatically transfer, etc. I prefer to do it manually. As the situation, even if we are in descent, is getting a bit dire on the right side, I'm not caring that much about the center of gravity, so I'm gonna stop the transfer to the front and I'm gonna pump fuel on the right side. It's gonna also affect the CG a little bit, but less, because these tanks are, as mentioned, really in front of the aircraft. Stop the pumps first, close the inlet valves, and open another route. I don't really care in which tank it goes, because they automatically feed in both of them. And by turning on the pumps again, fuel, you see, is rising. It's automatically pumped to the right side. I'm getting a little bit of a misbalance, but we are in descent. This is no longer relevant. The CG is still getting a bit forward, so we're actually achieving both purposes. Not for long, but it's going forward. We have meanwhile lost quite a bit of speed. Still supersonic, approaching normal airliner altitudes, flight level 400, and transitioning to the standard flight envelope of commercial airliner. Still a delicate plane, needs a lot of time to lose energy, and uses again a lot of fuel just to do the final and the approach. Fuel situation on the right is now good. That's alright. We're no longer on low fuel level warning here, so we could actually stop the transfer, but CG is still going forward. As soon as we reach 54, the whole balance CG thing is alright, and we can just stop pumping fuel altogether. I have enough now on the right side. Gonna close these valves and open them up again. Fun, I think. Almost subsonic now, 40,000 feet, and the trim is correct, pumps are stopped, valves are closed. I think we can leave that for landing. Fuel situation is much better again, almost balanced on left and right, so we're good there. We still need to change, we should have done that much earlier, sorry. To climb, doesn't change that much, and turn on our landing lights a bit early, but we have other things to do later on. Next little change, approaching 360, 340, gonna reduce speed to 325 and to flight level 240. Descending to 25,000. Soon we're gonna go to 10,000 feet, reduce to 250 knots. Not immediately, a bit later on. We need to check performance data for our arrival, and the approach speed is 220 about, and our weight at the moment is indicated here, a bit small, 122 tons, and according to the manual that puts us at about 170 knots landing speed, final approach speed. So 212, 220 at approach, and 170 for landing. 24,000 down to 10. Again, altimeter doesn't play a role, and the landing lights we turned already on. I'm starting to gradually reduce speed. We are about 50 miles from the next waypoint, which is the entry point, or close, very close to the entry point to the ILS where we need to be at 2,000 feet. About 16,000 feet, still 275 knots. I'm gonna change to RAD now, so I can take control of what's indicated in the VOR, because we have pre-programmed the ILS. I put the same track in as is in the INS at the moment. You can change to RAD and go to track. Plane should actually continue to fly, but now you are controlling it via the track setting. We are approaching the entry point, 2,000 feet, where we're going to turn to the ILS heading 224. As soon as the beam comes in Flight Simulator, the Autopilot, we go to glide. We could also do just a VOR lock or fly the whole thing manually, of course. Still too fast, but approaching entry point 2,000 feet. Expecting ILS to become alive coming in, and then go to glide slope. Visor down if we can get our speed under control, which at the moment is too high. Now that was a botched approach. Gee. Anyway, manual worked kind of, and the landing was fine. So every safe landing is a happy landing. The important stuff was the trimming, supersonic flight. That's the important stuff in this tutorial.